Okay, so from the last video, we talked about linear ODEs versus nonlinear ODEs. This basically, this slide is Theorem 1 in your book, which I'll go over. But I want you to remember that we are solving differential equations using a different method in this section because it's our differential equation is not separable, as we saw in a previous video. So that again, that's why we're doing this. So this is again theorem 1, and your book says a first order, or I basically paraphrased a little bit. If you want to write the exact words in your book, that's fine as well. So we have again a first order linear ODE. So if you have a first linear ODE of this form, where P and Q, okay, are continuous functions, that is functions of x, on an open interval I, right, containing our x naught, right, because we're given a differential equation and we're given an initial condition. Hence, this should be, we call this an IVP, right, an initial value problem, because we have our equation and we have our initial condition where we're starting. So if we have this information, then this differential equation has a unique solution, okay, y of x. And I know in some of the videos, I know it was the first video, which is fine, some of you are saying yx. Make sure you do say y of x, right? Y is a function of x. T is a function of x. So you do need that of, because if you say yx, then that's implying that it's a product. So again, just practice saying that as y of x on some interval I. Okay, so this equation here, in the last video, I believe, right, so this guy is our y prime, and let me change just the colors here. Well, I guess let's do blue. So I called in the last again video, this was a of x, y prime, plus, this was my, b of x, and this guy was my c of x. Okay, so notice I have the same thing here. The only difference is my a of x here is actually 1, which is nice. So our, I guess you can think of it as a leading coefficient, but our leading rate. Our a of x is 1, right? So the book is just calling it p and q. And again, initial condition, and let's see, anything else I want to say regarding, well, actually, okay, so this is the theorem we're going to use, and I'm going to quickly write, or actually, you can write it from the book. Let me actually just write the page number. We are going to be using, so if you look on page 47 of your textbook, the bottom right, well, the bottom of the page, it says method solutions of first order equations, and there are 4 steps. So I encourage you to write those down, and I'm actually going to be, excuse me, the next problem in the next video, example 1, I'm going to be referring to these steps. So make sure to write those down, and then you will be ready to attack the first example.